Hello everyone, I'm Stefan. In this tutorial we're going to talk about inverse functions. What is an inverse function and how we can find it and what does it mean. First of all, to find the inverse function of a function, the function has to be one-to-one function. What does it mean, one-to-one function? Each value of the domain has only one value in the range. For example, if we have A, B, C, D, and D, E, F, G, H, should be each one has just one value, can be one has two values. One-to-one is something like this, couldn't be something like this. For example, this A could be here as well and A and B here as well, means there are two values has same value in the range. And this is how we will write it down. If we have f of x, the inverse function is going to be f minus 1 x. This doesn't mean the power minus 1, it just means the inverse function. And if we have the domain of f minus 1 inverse function of f is equal to the range of f, and the range of f minus 1 is equal to the domain of f. Means if this is the domain, for example this is the domain of f, and this is, we can say, the f, and this is the range, we can say the r, we can say the rf. This is the domain, this is the range. In other side, this is will be the range of f minus 1, and this is the domain of f minus 1. This way you call it inverse, you inverse them. Is one like this and the other one is like this. You can see inverse. And y has to be one-to-one function. I will show you why. Y has to be one-to-one function. Imagine we have, for example, this table here. We have some table like this. We can just call it domain and range, and we have these values here. For example, 0 give us 1, 2 give us we say 0 give us 0, 2 give us 1, and 3 give us 1, and 4 give us 1 as well. 5 give us, for example, 3, and 6 give us 4, and 7 give us 8. Let's try to block those points here. What are we going to get? Program in pink. First one said we have 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7, 8. We said 0 give us 0 is going from this point here, and we have 2 give us 1, 2 give us 1 is here, and 3 give us 1, 1, 2, 3, 3 give us 1 as well is here, and 4 give us 1 as well is here, and 5 give us 3, 5 is here, 1, 2, 3 is here, 5 let's say is here, and 6 give us 4, 6 give us 4 is here, somewhere here, because 4 is here, and 7 give us 8. 1, 2, 3, 4, 5, 6, 7, 8, 8 is here, and 7 give us 8. Let's see if we block this point here. That's fine. This is a function. So let's take, for example, this is a function. This is the domain of f, and this is the range of f. But we will have opposite now. It will be, this is the domain of f, the inverse of f, inverse function of f, and this is the range of inverse function of f. So it's going to be opposite. And let's see what we're going to get. Change a different color. Take this one here. So 0 give us 0, that's fine. And we have 1 and the range give us 2. 1 here is going to give us 2. It will be something here. 1 is giving us 2 is here, right? And 1 is giving us 3. 1 is giving us 3. And 1 is giving us 4. And 3 is giving us 5. 3 giving us 5 is here. And 4 is giving us 6. 4 giving us 6 is here. And 8 giving us 7. 1, 2, 3, 4, 5, 6, 7, 8. 8 something here give us here. So it's going to be something like this. Something like this. And how we see this is not a function. Why? Because function has each value here. Each value in a domain has only unique value in the range. It can be, for example, like this. This is not a function. Like this, for example, two values from the domain has one value in the range. That's okay. It's still a function. But when you have one input has two outputs, this is not a function. Therefore, this is not a function. That's the reason why it has to be one-to-one function. If you have a function like this and when you are putting the opposite, it will be something like this, and this is not a function. That the reason has to be, you have to test it with horizontal lines to see if it's a one-to-one function. If it is, it will be okay. If not, you have to take a domain of that function. For example, we can take this domain, for example, from here. From here, for example, we might have a you can find the inverse, but since this part here is not one-to-one function, you can do that. And another things about the inverse function, relationship between inverse function and the function and the real function is, if we have, for example, the graph, let's say the graph of x squared is like this. So let's find it. Anyway, we're here, let's find it. So we have f of x is equal x squared. How we find let's call it y, if x is equal y. How we find the inverse function? What we do, we switch these two. We make x, we substitute the x with the value y with the value x, and the x with the value y. Thus in this case here will be y squared equal x, and then we solve for y. So let's do that just to show you what is going on. So we have, let's change this, we have y squared equal x, so, and we solve for y, therefore y is equal square root of x. So to find the inverse function for x squared, you have to find it only in the positive side, otherwise you can, because it will be negative here. So this is x squared, we say. Let's find how the f of x equal x square root of x, and this is equal here to minus 1. So this one, it will be, they are both passed from 1 here. So it's going to be something like this. And to test the inverse function with the real function, they have to be symmetric to this line here. It has to be this line is line of symmetry, is y equal y equal x, is axis of symmetry all the time. How you see, take this point is here, point is here. If you find the inverse function and you try to test it with the symmetry with this line here, x y equal x, and you don't find it that is symmetric, means something wrong. So let's find another function and find the symmetry. So let's do an easy example to find the inverse function, and then we can put it, we graph them both, you see how are symmetric. Let's just take something simple so we can visualize. It's easy to see the symmetry. Let's see f of x equal x plus 5. We say this is y, therefore we change x y, so it will be x equal y plus 5. Then we solve for y, it will be y is equal x minus 5. So this is the inverse f minus 1, and this is f of x. So let's try to graph them both and see the symmetry I was talking about. So this is the graph. Let's put some 1 2 3 4 5 4 5. We didn't need a lot because just a line is very easy to graph. We just need 2 points. So we have here the points when x equals 0. This is going from 5 1 2 3 4 5 from here, and when x equal minus 5 is going to be 0 1 2 3 4 5, just an easy way. So this is the graph here, and another graph we have when x equals 0 is equal minus 5 1 2 3 4 minus 5 is here, and when x equal 5 will give us 0 1 2 3 4 5 is here. Now we can see that they are really symmetric, and you see the line of symmetry is this one here, x equal y is here. You see are symmetric. Let's find another example, maybe some lines going something like this, it will be negative. So let's do y equal f of x, this is equal minus 1x, f of x is equal minus x plus 3. So we will say we switch x and y, so in this case it will be x is equal minus y plus 3. So we solve for x, for y, it will be y is equal x minus y is equal x minus 3. Therefore y is equal minus x plus 3. So in this case it will be the inverse function is same line. Wow, it's interesting. Why? Because the line is going like this, and you see is the symmetry here. So let's write the line when x equals 0 y is equal 3. x equals 0, y equal 3, 1, 2, 3, and when x equal 3 is equal 0 is going from here. And you see this line is a symmetry itself. If you take this point is here, if you take this point is here, is a symmetry. This was interesting. So let's find another line, maybe something like this. Let's find another line so you can see it. Let's say we are going to find a better line to find it. F of x equal y is equal 3x. Just do 3x. It's very easy. Just 3x. Therefore, let's find something you can see it. Very straightforward. So we can switch here is x equal 3y. Therefore, f minus 1x is equal 1 over 3x. So let's do this one here. Have the graph here. We have 3x. It will be when x equal 1, y is equal 3, and pass by 0. Let's 1, 2, 3 here. So it will be here. So we know this line is going from here, something like this. Something like that. And let's find another one. And this graph is present, this one here, the f of x. Let's find the inverse of it, is equal 1 over 3x. When x equal 3, when x equal 3, y it will be, if inverse, it will be just 1. Let's do that. 1, 2, 3. It will be just 1 here. So we'll pass by this point here and by 0. When x equals 0 is going to give us 0. So it will be from here as well. Let's write it down with a different color. So it's going to be this line here. So it's here. So this is the line. And how you see is a really symmetry with the x, y equal x, this line here. Whatever your point you took, you see that is a symmetric. This is the idea. If you take, for example, this point here, the symmetry, for example, is here. Take this point is here. At 0, symmetry is 0. If take is here, is here, is here. Every point you take is, it will be symmetric, and this line is y equal x. And let's now find some inverse functions. We apply same way we're doing, just it will be a little bit maybe harder. Let's say that f of x is equal 1 over x plus 1. So we said let's say is equal y. We change y and x. So x will be here and y it will be here. Therefore it will be y is equal, is x will be x is equal to 1 over y plus 1. We just switch them. Therefore we can move that y other side. It will be y plus 1 times x equal 1. Therefore y plus 1 is equal 1 over x. Therefore y is equal 1 over x plus 1. So if we have a function like this, and this is, so therefore it will be x minus 1x, that doesn't mean power, just inverse, they write it like that, is equal to 1 over x plus 1, and always they will be symmetric. How we say before, is very easy, just manipulating the algebra, that's it. Let's have another example. Let's say we have f of x is equal square root of x minus 5. So we do same thing. So we switch y and x. This is y. So y, it will be equal to x plus 5. So we raise the power for both. So let's switch them first. It will be x equal square root of y plus 5. And now we can raise the power for both of them. Just raise it here. So it's going to be x squared is equal to y plus 5, and then we insulate y, will be y is equal x squared minus 5, and this is equal inverse function of f of x. It's very just pseudo algebra, and that's it. Just the goal, what you have to do, you have to switch them and then solve for y. It will be y here, you have to solve for it. Let's try to do last example. So to get it, it's very simple. So let's do another example. For example, something like this: f of x is equal y is equal to x squared minus 1 over x plus 1. We say we switch between x and y. We put x here and y and all the values of x. So what we're going to get, it will be x is equal to y squared minus 1 over y plus 1. Therefore we have to find how we did it. We see that we have here, this here we can write it as y plus 1 times y minus 1, because this is 1 squared. Applying the formula that say a squared minus b squared is equal to a minus b times a plus b. Same formula we're going to apply here, so hopefully we can cancel. Therefore it will be x is just equal to y minus 1 times to y plus 1 over y plus 1. So we can cancel these two, and we will end with x is equal y minus 1. Therefore y here will be just x plus 1 equal inverse of f of x. So inverse of this one here, the inverse function of this one here is this one here. Very simple. And hopefully you'll like this video. Please subscribe and share, and thank you for watching.